This is a theory of computation term project on halting problems and primitive recursive functions by Shehan Su, Jiun Zhang, David Odele, and Badr Al-Zaidi. We're going to be discussing about primitive recursive functions and some ways of dealing with halting problems and limitations of these papers as well. A function is called primitive recursive if it can be obtained from initial functions and or recursion of composition and or recursion. This simply means calling a function over and over, or a function calling itself. But not all computable functions are primitive recursive. From what we have discovered in this article, we understand that the primitive recursive functions are created by trivial identity functions that in turn create successor functions which lead to primitive recursion. A specification of a sequence of function f0, f1, f2 through fk, where fk, I beg your pardon, is either an initial function or is defined from previous functions in the sequence by composition or recursion, and fk is equal to f. This phrase will be used for the base for logic on our paper at the Rice's theorem part.
The reversible primitive recursive function is a bijective primitive recursive function that is reversible. Its inverse exists and is computable. Reversible primitive recursive class is subset of class of bijective primitive recursive function, which is a subset of primitive recursive class. The Halting problem is a decision problem about the properties of computer program, whether the program will finish running or continue to run forever on some input, especially input is a string in Turing machine. So we will see Rice theorem first, which is the one of the classic theorem that proved the Halting problem is not computable. And also we have a Rice-Shapiro theorem that generalizes the original Rice theorem that states in any non-trivial property of computer function that can be decided is recursively enumerable when its input function is given by one of its indices. And we will use the theorem to show that we can partially solve the whole problem by restrict the condition and range of set very strictly.
As we said before, Rice-Shapiro theorem says any non-trivial property that can be computed as is recursive. By definition, a set is semi-decidable if and only if it is recursively enumerable, and a set is decidable if and only if it is recursive. The author says if a set A is recursively enumerable, then it's equivalent to say that A is an effective union of open sets in a topological space named Ver space. So decidability can be transformed into the topology-related mathematical problem. Our Riemannian function is called Riemannian just because it is such a fast-growing function. So we will use the property from our function. Dixon's lemma shows that there are finitely many bad sequences, i.e. strictly decreasing sequence over the natural number. Such a sequence has finite lengths, hence an algorithm based on it does halt, and we can compute its complexity with lengths which can be easily done. So reversible primitive recursive function and a Turing machine based on a reversible primitive recursive function. At this point, we reduce the number of instructions to find the inverse of the computation. In here, the functions are defined on a set of integer, not on a set of natural number.
So, recursive Turing machine and classic Turing machine are proven to be equivalent. Hence, they have the same computing power, except the former one can compute the inverse of the function without significant loss. No, increase in the number of computations. So it can lead to another breakthrough of dealing practically with the halting problem. But recursive Turing machine does not avoid the halting problem, but it might be helpful in redesigning and testing an algorithm. And in sequence analysis with Ekmanian function, this method is designed only for a low complexity algorithm, so one cannot be verified if it works with the algorithm with higher complexity. And for the last one, lies like a theorem and implementation based on it has yet to be found. So, in conclusion, it is proven that halting problem is indecidable, but there exists certain method which can deal practically with the halting problem in the realm of primitive recursive function. And
This is the end of our presentation. Thanks for listening.